So in this, we are going to discuss about the object-oriented analysis in object-oriented software engineering. So in object-oriented analysis, we are going to see about the identification of relationships. In object-oriented analysis, the classes can connect to each other, having different kinds of relationships. These relationships provide collaboration among classes. A system consists of classes and objects. The system model depicts the communication among classes. The instances of a class communicate through sending messages. So, in identification of relationships, we can take the example that book is issued after the issue book message is received by the issue book object. Thus, a message is sent from one object to another. A relationship provides a channel through which instances of classes communicate with each other. They represent connection among instances of classes. There are five types of relationships among objects. They are association, aggregation, composition, dependency, and generalization. Relationships along with their notations are given in the table 5.4. Association provides structural connections between instances of classes. Aggregation provides whole part kind of relationship between classes. Composition provides strong aggregation between classes. Dependency signifies that changes in one class affect the other class. Generalization signifies parent-child relationship among classes. And the notations for these relationships are also mentioned in table 5.4. That is the issue book control class, which is managing the transaction class in 5.8. So we have the transaction class, which is going to be managed or controlled by the issue book controller class. When two classes are in association relationship, a role may also be associated between them. A role which describes the function a class plays in an association. Example, a member may play a role of a student, faculty or employee when it is associated with transaction class. On the end of each association shown in figure 5.9, multiplicity is specified. For example, in figure 5.9, so we have a member as the entity class and we have the transaction class also. And in this library management system, a faculty can able to take a maximum of 10 books. And for a student, they may take the books number of books as with a maximum of 5 as a limit. And for the employee, the maximum limit of the book issued may be 10. So that is mentioned here, and the relationship which are mentioned here. So next one is an aggregation. The figure 5.10, which is showing the aggregation relationship between the library entity and the book entity. The aggregation relationship models a whole part type of relationships. That is, it depicts that a class is a part of another class. Some operations in the whole class may be applied to the other class. Aggregation represents has a relationship. The notation is a line with a diamond at the end, that is the class denoting the whole. So in the library management system, book may be issued to a student or a faculty or to an employee. The relationship between the book class and the library class is aggregation, which means that the book class is a part of the library class. That is, a book may be issued to a student, a faculty, or an employee. So it is a book is a part of your library class. The next is the multiplicity. Multiplicity represents the number of instances of a classes related to one instance of another class. It depicts how many objects of a class are related to one object of another class at a given time. Multiplicity can be specified in association and aggregation relationships, and it is expressed by a range of values as shown in figure 5.7. Thus, a student can able to take a maximum of 5 books. So, in a transaction, It is given as the multiplicity may be ranging from 0 to 5. So multiplicity can be shown as many that can be represented as 0 star and one or more which can be represented as 1 double dot star and exactly 1 means it is 1. So the multiplicity can be denoted with a generic relationship as minimum value double dot maximum value. Some commonly used multiplicity indicators which are given as follows. 1 represents 1, many is 0 to star, 1 or more means 1 double dot star and 0 or 1 means it may be either 0 or 1. So 0 double dot 1, 3 to 5 that is the specific range we can able to represent from 3 to 5 means we can give the minimum value as 3 and maximum value as 5. The next one is the composition. Composition relationship represents at a strong form of the whole part relationship. When two classes are having composition type of relationship, the part class belongs to only the whole class. Example, in a university, the departments belong to only the specific university. The notation used for composition relationship is a line with a filled diamond at the end, that is to the class denoting the wholes as shown in figure 5.12. That is, you have an university and the department, and the department which will be not which will be only once specific to a particular university. So that's why the university may consist of one or more departments, and the department only one, the name of the department, for example, computer science and engineering, only one which is available in an university. So it is represented as a to a specific departments may be available only one in the university. The next is the dependency. The class referring another class is represented through dependency relationship. Hence, the change in the class being referred affects the class using it. It is depicted by a directed dashed line. Dependency relationship is unidirectional. It exists when the instance of a class is either passed as a parameter variable in a method or used as a local variable in a method of another class. The aim is to minimize dependency relationship among classes. It increases complexity and decreases maintainability of the system. For example, a university which is maintaining the record of programs running in a school, consider a school schedule class which is dependent on programs of the university as it uses the object of program class as parameter to its member add. So thus the school schedule class is dependent on program class as shown in figure 5.13. So the school schedule which is depending upon that program class, so which is represented as a directed dotted line. So this is representing the dependency relation. So the next one is generalization, which is a very important relationship. Generalization is a relationship between the parent class and the child class. This depicts inheritance relationships. This is known as a ESA relationship. So in generalization, the child inherits all the properties of its parents, but vice versa is not true. The child also consists of its own attributes and operations. When the operation of a child has the same name and signature of its parents, it is overriding the operation of the parent class. This concept is also known as polymorphism. It is shown as a solid line with an open arrow head and points towards a parent class. A class can have zero or more parents. When a child inherits features from more than one class, it is known as multiple inheritance. Thus, in multiple inheritance, a class has more than one parent class. Example, in LMS, student, faculty, and employee are all members of a library. They may have their own attributes but have some attributes in common which are placed in the base class member. In figure 5.4 depicts a generalization relationship. Here, student, faculty, and employee entity class are children of the member class because they are the members of the university management system. Thank you.